Hi guys, this is Sarah here to film my awkward homework video for problems 30 and 31 in chapter 4. So 30A is asking, can the hydrolysis drive the formation of glutamine? So basically, you're trying to determine if this coupled reaction is spontaneous. So you set up this equation and basically have to find out change in G. So the given values are change in G of formation of glutamine and change of G of hydrolysis of ATP. So you plug those values in and end up getting negative 17 kilojoules per mole. So this is spontaneous, and therefore, yes, hydrolysis of ATP can drive the formation of glutamine. So this coupled reaction is spontaneous. For B, it's asking how many moles of ATP must be hydrolyzed to form 1 mole of glutamine. So you would set this equation up, and it's going to be the same given values, except for you have the addition of, we know there's 1 mole of glutamine. So if you plug in the given values, and these are set equal to each other, then you can determine that the minimum amount of ATP required to form 1 mole of glutamine is 0.46 mole. So moving on to problem 31, it is asking about a coupled reaction between the formation of acetyl phosphate and the hydrolysis of ATP. And it's asking what is the minimum number of ATP molecules that would need to be involved in this coupled reaction. So the given value here, you have to look back to problem 30 and look at the change of G of hydrolysis of ATP, which is shown, and then they give you the change in G of hydrolysis of acetyl phosphate, which is negative 42.1 kilojoules per mole, and you have to know that the change of G of hydrolysis is going to be the opposite sign of the change in G in formation. So the given is negative, so you just change the change of G of formation to a positive 42 kilojoules per mole. So you set up the same equation basically as the last problem. As you can see, I wrote hydrolysis, but I crossed it out and put formation to save paper and not rewrite it. But you set up the same equation and you plug in the values that you were given, as well as 1 mole of glutamine. And you plug it in, solve, just as you did the last one. For this one, we got 1.36 moles of ATP, and they are asking how many molecules, so you do a little stoichiometry, use Avogadro's number to determine that the minimum molecules of ATP required for this coupled reaction is 8.1 times 10 to the 23 molecules. And that's it.